So, welcome. And in this little clip, I want to show you how easy it is to have GitHub do security analysis on your code. And I want to start showing you the result. In this simple repository where I am playing with some .NET Core crypto API, I have my security tab. And in my security tab, I have another section dedicated to code scanning alerts, and in which I got some previously scanning code alert that are telling me that I have some sort of problem, security problem in my code. And how difficult is having GitHub on giving me this suggestion? Actually, it is really simple because you can simply create a special workflow called, in my situation, CodeQL analysis, and it's auto-generated by a wizard. And the name suggests to you that this is the action that perform CodeQL analysis. And CodeQL is the instrument that is going to analyze your code and find security problem. The action is some sort of predefined one. So the only thing you can change is the branch you want to monitor. So in this simple example, I just want this analysis, CodeQL analysis, to be triggered only on master and develop branches. And for pull request, I'm enabling this action only when you issue a pull request on develop. And I have also a schedule as an example. But the action is really simple. It's run on an Ubuntu machine, and it's actually auto-generated by a wizard. The only important thing I've changed is the language. I'm instructing the component that I'm using a C# project, so it can more easily understand what's going on and what kind of code the tool is expecting to analyze. And then it is a really simple action where you have a standard checkout of the code and a special section that is initializing CodeQL using a language. So it is installing, configuring, initializing, telling the environment that I'm using metrics language as C# in my situation. And then I have a special step called auto-build, because CodeQL is capable of analyzing code, but you need to build the code if you are using compiled languages like C# or Java or C++. Auto-building is not useful if you are writing JavaScript or Python code. So with these simple action steps, auto-build, what happened is the action is trying to compile whatever is in the repository. So in my situation, since it is C# project, it is expecting to find some CS project or .sln file in my repository. And that you have some sort of helping comment. And if the auto build fails because maybe your solution needs some sort of prerequisite to build, you can simply remove the auto build and put here the code that is going to compile your solution. And finally, you have, after you compile your code, you have the step that is actually performing the real CodeQL analysis, and it is also a predefined step taken by the CodeQL action. Okay, once this action runs, you can find it in the Actions tab that it is actually run on my code, and this is the CodeQL. And if I look at the output of the action, I have one job completed, and you have the analyze C#, and you can see that it actually really perform an auto build, and it's attempting to automatically build C# code. So it is running some sort of command. It installed .NET Core, and it's to running .NET Clean, and it is actually finding my solution file. So I know it is going to work. So the auto build for this simple project is enough to have CodeQL run. The final part is when the CodeQL scanning run, if it finds some sort of vulnerability, it put you a security alert in code scanning alert section. As an example, I have an encryption using ECB. So the CodeQL analysis find that in a piece of my code, I'm using the electronic codebook encryption mode. And we know that this is vulnerable. But in this situation, it is actually in some unit test code. So it's not real vulnerability. It's a code that is running on test. And that's important because the old security tab, the old code scanning alerts can be dismissed with a reason, such as an example, you can see the history. I can't forget, close this as used in test and reopen and close. So you can close, reopen an issue. And when you close, you can give a reason, such as used in test. So I know that this is a vulnerability, but it's used in unit test. It's unit test code, so I can assure you that it's not a real vulnerability. But this kind of analysis is somewhat simple. So you're expecting the code scanning to look at your data, find some sort of constant, like so the cipher mode ACB, and automatically flag as critical. But let's see some other more interesting issue, like our coded credential. So in this alert, the system is telling me, hey, I found some more coded credential. But how it can find this piece of code and telling me that this is indeed an hard-coded password? Yes, the good part of the CodeQL analysis is it actually follows the flow of code. So it is telling me, hey, the hard-coded value and other password flows in the code to the password parameter in object creation of type RFC2898 derivative bytes. So yes, it's interesting. If I click here, it tells me, okay, you are in this piece of code. It's a unit test. You are passing this kind of hard-coded string in a function. And then this hard-coded string flows between function call, method call, function call, method call, and until it ends in this kind of file, in this file, encryption utils, and it is used in a constructor with this specific class, with a constructor of this specific class. And so the CodeQL really knows that this is going to be used as a password. So it's a vulnerability because it's an hard-coded password. If I'm not sure if the tool follows all the flow of the code correctly, you can also show the path. So it is going to show you all the steps you followed in your code, such as function, method after method, function after function, method after method. You hand after a lot of calls to this kind of final file, final encryption utils file where he found the use as a password. So it is a little bit more complex analysis than simply looking at the code, but it is following the code. It is following all the path of your code, trying to understand if there is some path with problems. And when it finds a part of the problem, it gives you the alert. And as the previous alert, I dismissed this alert as used in test. Another interesting aspect is the detection. So the code analysis is telling me that the first time it saw this vulnerability was this commit. And so you can really understand the who and when this vulnerability was introduced. And then it is telling you that it's going to flow in various branches. So it is appearing in this commit, and then it appeared in a branch called develop, and then it appeared in the branch master. So we can look at the flow of this vulnerability between maybe the feature where it was introduced, when it was closed and merged into develop, and when finally it is it went on master. So it is really useful because you can really flow the lifetime, the life cycle of this vulnerability in your code. And you should, in a situation like this, you should put some sort of good practice like pull request in place to avoid vulnerability to flow from the feature to the develop and on the master branch. And finally, you can have a set of predefined label put on this issue. And it's particularly interesting, the CWE code of this vulnerability, because if you are not sure on why this is a vulnerability in this situation, it's really simple. You have encoded a password, but there can be situation where you don't understand why the code is really vulnerable. So you can simply search for, I don't know, 798. So you search CVE 798, and you are redirected to the Mitre site, and then you have a good explanation on why this is a vulnerability, and you have all sort of information, and you can simply came from the code you find here. And clicking on a label will filter all the scanning alerts based on this kind of label. So in this situation, you can find that you have 5 related to the CWE 321. So you can even try to understand how much common is a particular vulnerability in your code. And maybe if you find that there are certain area of your code that are more it's more affected by a specific vulnerability, you probably need to modify your process and to make probably mandatory training to your developers for avoiding this kind of vulnerability to flow into production code. And that's all. As you can see, it's really easy in GitHub to create an action. It is automatically created for you. It can auto-build the code for you. And this gives you automatically a sort of a series of code scanning alerts. So it immediately point the finger to some point on your code that need review. Goodbye.